Welcome to Chapter 5, Module 2, Price Elasticity of Demand. Segment 1 focuses on measuring price elasticity, and it also will introduce the midpoint formula. What will you learn in this segment? You will learn why price elasticity of demand is always negative. You will learn how to measure price elasticity, given that data about price changes and quantity changes are provided. You will learn how to measure price elasticity based on data about changes of demanded quantity and changes in price. You will learn how to measure price elasticity between 2 points on a demand curve. You will learn under which circumstances demand price elasticity is high and when it is low. And finally, you'll learn about important ranges of elasticity of demand. Price elasticity of demand is always negative. Why is this? According to the definition of price elasticity, we have to divide the percentage change of quantity by the percentage change of price. And this result is always negative. Why? There are two possible cases. The first one is the price increases. Then the percentage change of price would be positive. A positive percentage change of price leads to a decreasing quantity demanded. Therefore, the change of quantity would be negative. If we divide something negative by something positive, the result will be always negative. What if the price change is negative itself? So the price decreases. If the price decreases, quantity demanded increases, which means that percentage change of quantity would be positive. Then we divide something positive by something negative. The result again will be negative. That is actually the reason why price elasticity of demand is always negative. After you learn that price elasticity of demand is always negative, the question arises how to measure price elasticity. If the percentage change of quantity and the percentage change of price is given, then we would just divide the percentage quantity change by the percentage price change. But what if, like in our example, these percentage changes are not given? Then we have to calculate them first. To show how to calculate these percentage changes, we start with the quantity demanded. In general, a percentage change is calculated by the change of the variable, so the change of quantity here, divided by the level of the variable. So what is the change of the variable? The change of the variable is the new quantity minus the old quantity, 35 gallons minus 32 gallons, which equals minus 3 gallons. Now you have to divide by the level of the quantity. This could be either 32 gallons or 35 gallons. In high school you learned to use the initial value, which would be 35 gallons. But there is actually no reason to use the initial value, except this is a common convention. We use another idea here. Instead of using the initial value, we use the average of the initial and the new value. This is 35 plus 32, which adds up to 67, divided by 2, 34.5. You probably can see that 34.5 is exactly the middle between 32 and 35. That is because it's an average. And this is why this formula is called the midpoint formula. So again, instead of using the initial value for the level, we always use the average of the new and the old value to calculate the level. Minus 3 divided by 34.5 equals minus 0.087. To turn this value into a percentage value, you have to shift the decimal point 2 digits to the right. The result is minus 8.7. When you do this calculation, write it down on a piece of paper and then you use it later. Here we can just substitute it in the formula. Because we don't know the percentage change of price, we have to calculate it from the numbers of the example using the midpoint formula. First you have to calculate the absolute price change, which is 320 minus 240. The new value minus the original value, and the absolute price change is $0.8. Next, you have to divide $0.8 by the level of the price, and again we use the midpoint formula to calculate the level. 3.20 plus 2.40 adds up to 5.60 divided by 2 gives 2.80, which is exactly the midpoint between the new price and the old price. 0.80 divided by 2.80 gives 0.2857. To turn this value into a percentage value, shift the decimal point 2 units to the right. And the result is 28.57%. Write it down on a piece of paper for the final calculation. We will substitute it here in the formula. When you have the two percentage values for the quantity change and for the price change, you only have to divide the percentage value of the quantity change by the percentage value of the price change, according to the definition of price elasticity. The result is minus 0.3. Minus 0.3 means that the quantity decrease is approximately 1/3 of the price increase. Or, which is basically the same, if the price increases by 1%, quantity demanded would decrease by 0.3%. You learned how to use the midpoint formula to calculate percentage changes in price and quantity demanded, and then based on these percentage changes to calculate price elasticity of demand. But what if the data are not provided? If, like here, you are supposed to calculate the price elasticity of demand between 2 points on the demand curve. This actually looks way more difficult than it is. You just have to find out what are the values behind these points, and then you can use the same procedure you already used to calculate price elasticity of demand. First, you find out which of the 2 points is the initial point and which one is the new point. Actually, to calculate price elasticity, it is not relevant which of the points you assign the new point and which one you assign to be the initial point. So we consider the upper left point as the initial point and the lower right point as the new point. We start with finding out which price and which quantity demanded goes with the initial point. First, we go horizontally from the point towards the price axis, where we find a value of 14. Therefore, the initial price is 14. Then we go straight down from the point until we reach the quantity axis and find that the initial quantity demanded is approximately 1.6. Now we go to the lower right point and find out first what is the price which goes with this point. We go horizontally to the left and find that the price P1 of 8 goes with this new point. Then we go straight down to the quantity axis and find that the quantity demanded of approximately 3.5 goes with the new point. To summarize our results, the price decreased from 14 to 8, and the quantity demanded increased from 1.6 to 3.5. Which complies, by the way, with the law of demand. After we generated the relevant data, we can use the same procedure than we used before with the midpoint formula to calculate first the percentage change of quantity, then calculate the percentage change of price, finally dividing the percentage change of quantity by the percentage change of price to get as a result the price elasticity of demand. The quantity demanded increased from 1.6 to 3.5. Therefore, the change was 3.5 minus 1.6, which equals 1.9. To calculate the level of quantity, we again use the midpoint formula. 3.5 plus 1.6 divided by 2 equals 2.55, which is exactly the middle between 1.6 and 3.5. By dividing 1.9 with 2.55, the result is 0.7451. To turn this into a percentage value, we have to shift the decimal point 2 digits to the right, and the result is 74.51%. We substitute this value into the price elasticity formula and then calculate the percentage change of price. To calculate the percentage change of price with the midpoint formula, we again calculate first the absolute change of price, which is 8 minus 14, the new value minus the old value, that equals to minus 6. Then we calculate the midpoint for the level of price by calculating the average of the old and the new price. So we add 14 plus 8 and divide the result by 2, which gives us 11. And if we divide minus 6 by 11, the result is minus 0.5454. To turn this into a percentage value, we shift the decimal point 2 units to the right, and we get minus 54.54%, which is a percentage change of price. This goes in the definition formula for the price elasticity. And from this formula you can calculate the price elasticity just by dividing the percentage change of quantity 74.51 by the percentage change of price minus 54.54. The result is minus 1.37. And the result is negative because we divided a positive quantity change by a negative price change. A price elasticity of demand of minus 0.137 means that the quantity demanded reacts approximately 1 1/3 times stronger than the initiating price change. Or, if the price changes by 1%, quantity demanded would change by 1.37%. After you learned how to calculate elasticity, I would like to talk with you about ranges of elasticity. The first one is not a range, it's actually a point. If the price elasticity of demand is 0, we call this perfectly inelastic demand. This means no matter how much the price increases, the demanded quantity will not respond at all. If price elasticity is between 0 and 1, we call this inelastic demand. And now we have to talk about what is meant by PED. PED is actually the price elasticity of demand without looking at the sign, so we ignore the minus. If we talk about small or big or greater or smaller than 1, we only look at the number. Mathematically, this is called the amount of a variable. Only the value matters, but the sign does not. So if price elasticity is small, smaller than 1, it's called inelastic. The decrease in demanded quantity is small in relation to the increase of price. Whatever the percentage price increase will be, the percentage decrease in quantity demanded will be always smaller than the percentage increase in price which triggered it. If price elasticity is exactly 1, we call it unit elastic demand. This means whatever the percentage price increase is, the percentage decrease in quantity will be exactly the same. And if price elasticity is greater than 1 and smaller than infinity, we call that elastic demand. A given percentage price change will always result in a relatively low percentage quantity change. This means no matter what the percentage price increase is, the percentage demanded quantity decrease will always be smaller. And finally, if price elasticity equals infinity, we call this perfectly elastic demand. In this case, even a very small increase in price would result in an infinite decrease of quantity demanded. In the next segment you will learn why these ranges of elasticity are extremely important when we discuss revenue. The last topic covered in this segment is the question under which economic circumstances is the price elasticity of demand high. I will focus here on 3 important determinants. The first one is, if close substitutes for the good exist, the price elasticity is high, otherwise it is low. Why is that? Here is an example. Price elasticity is high for apples, but low for gas. If the price of apples increases, consumers will reduce their quantities demanded a lot and will buy instead oranges, peaches, and melons, because all these fruits are substitutes for apples. If the gas price increases, it is way more difficult for consumers to substitute gas with something else. Instead of driving, because that needs gas, they could use public transport, they can just drive less, but there is not a lot of room for this. Therefore, they will not respond that sensitive to price increases than they would if the price increases for apples. The second topic is that in the long run, price elasticity of demand is higher than in the short run. We again use gas as an example. If gas prices increase, consumers will only demand a little less gas than before if we analyze a period of, let's say, a month, which would be considered short run. Why is that? We already mentioned it. Public transport or not driving at all are just not good substitutes for driving. In contrast, demand might significantly decrease when consumers have 2 years or more to adapt to the price increase. How can we justify this? In the long run, there are other substitutes for gas. This would be, for example, to drive a smaller car when consumers replace their cars, or buy a more fuel-efficient car when consumers replace their cars. But this takes time. Therefore, these effects, which would lead to a higher price elasticity, occur only in the long run. The last topic is extremely important if you conduct your own market research. The narrower a market is defined, the higher is the price elasticity of demand. Again, we use gas as an example. We know already that the price elasticity for gas in general is low. But if we define the market very narrow, instead of saying gas in general, we say Chevron gas, we will find out that the price elasticity for Chevron gas is very high. Again, the reason are substitutes. While there are not a lot of substitutes for gas in general, there are a lot of substitutes for Chevron gas. If the price of Chevron gas increases, consumers would buy Shell or Exxon or other gas brands. This means price elasticity of demand is very high if the market is very narrowly defined, like Chevron gas, and it is lower when the market is more broadly defined, like gas in general. What did you learn in this segment? You learned why demand elasticity is always negative. That was at the very beginning of this segment. You learned how to calculate price elasticity with the midpoint formula when the price and demand data are given. You learned to use the midpoint formula between 2 points on the demand curve to calculate price elasticity. And you learned about important price ranges of elasticity. At the end, we discussed what determines the elasticity of demand. With other words, under which circumstances is the price elasticity of demand high and under which circumstances is it low.